Okay, guys, now over to the second question. Now, remember, if you look at this system, this is a modified Atwood machine. So now this surface is a frictionless surface. That is no friction on this surface. Now we will find the net force on each of these bodies. Okay. So now with respect to this one in particular, so we now have the tension force. That is the net force. I'm trying to find the net force. The net force is the tension force is going up, so it's positive. While the weight is what? Going downwards, so it's negative. Okay, so it's just like doing T plus minus M1G. Okay, the weight is negative, so it's equal to mass times minus A. Minus that is equal to M1 times minus A. Remember, why is minus A is that the acceleration is downwards. You see the direction of the acceleration downwards. So we now have that T minus M1G is equal to what? Minus M1A. So therefore, T is equal to, you take this one to this side. That is, you add M1G to both sides. Then we now have that becomes M1G minus what? M1A. So this is the first equation for the tension. Now to the second equation for the tension. Remember, the tension is here and also here. So with respect to this one, remember, this surface is what? Frictionless. There is no friction. So in that case, we now have T is equal to what? M2 times A. In this case, it is what? Positive A, because the direction of the acceleration is what? Towards the right. So, right is positive, left is what? Negative. So this is the second equation. That is T is equal to M2A, equation 2. So when you equate the two equations, when you equate them together, when you equate the two expressions, we have that M1G minus M1A is equal to what? M2A. Okay, that is your bringing equation 1 and equation 2. So this is it. So remember, we are looking for the expression for A, the acceleration. So we now have minus M1A minus M2A is equal to what? Minus M1G. So we now have minus A bracket M1 plus M2 is equal to what? Is equal to minus M1G. So minus is here. We cancel it both sides. So we now have A bracket M1 plus M2 is equal to what? M1G. So therefore, the acceleration becomes equal to M1G all over M1 plus what? M2. So this is the acceleration, okay, of the system. That is when there is no friction. So let us consider the acceleration when there is friction. Now, when there is friction, when there is frictional force now, we have that. Remember, there is friction this time. So this is the frictional force. So FF. Remember, the frictional force FF is equal to what? Is equal to mu R. This is the normal reaction, okay? Along here, see the normal reaction. This is the normal reaction R, okay? So friction is equal to mu R. And R is equal to what? M2G, okay? So therefore, FF is equals to mu M2G. So this is our frictional force, okay? So remember, in the case where there is a friction here, you see this first equation for tension, it is still correct, okay? So, but the second equation we have to express it. Now we now have, right is positive, so therefore T. This is opposition force, that is the frictional force, that is T minus FF, okay, is equal to what? Mass times acceleration, that is M2 times A, okay? So FF is mu M2G, so T minus mu M2G is equal to what? M2A, okay? So therefore T is equal to M2A plus mu M2G. Yes. So when you now equate this one and this one, we now have M1G minus M1A is equal to M2A plus mu M2G. Okay, so remember we are looking for expression for A. Now we have minus M1A minus M2A. Okay, so we now have, we take this one this side, we now have equal to minus M1G plus mu M2G. So we now have minus A bracket M1 plus M2 is equal to minus G bracket M1 minus mu M2. Okay, yes, you know, G is here, so we bring it out outside the bracket. The same thing with minus. Okay, so we cancel minus both sides. We now have A bracket M1 plus M2 is equal to G M1 minus mu M2. So we now have that the acceleration A is now equal to G M1 minus mu M2 all over M1 plus what? M2. So this is the equation for the acceleration. Okay, this is it, equation for the acceleration. So this is it. Now, you know, after getting the equation for the acceleration, you can substitute it in any of these equations for tension to find the equation for the tension. Okay, so see you guys in the next video. So this one is the next one I will explain.